Welcome, advocates, to another episode of the Leading Equity Podcast, a podcast that focuses on supporting educators with the tools and resources necessary to ensure equity at their schools. Today's special guest is Mr. Ben Orlin. So, without further ado, Ben, thank you so much for joining us today.
Yeah, thanks, Dr. Akins. I appreciate being here.
Oh, Sheldon is fine, and the pleasure is
Okay.
all mine. I appreciate you and your time for spending a Sunday morning or afternoon. I'm not sure what side of town of the United States you're on, but thank you for spending your Sunday time with me.
Yeah, no, appreciate it. Yeah, Minnesota, which is right now it's fair country. The state fair just started here, and so it's like that's all anybody's thinking about or talking about.
Okay, all right, cool, cool. One of these days I'm gonna make my way out there. I haven't been out there in a minute, so but I'm excited for today's conversation. But before we get into today's topic, I'd love for you to share a little bit about yourself and what you currently do.
Yeah, I think so. But I think of my career as being the two halves. I teach and I write, and it's kind of moved over the course of my career how those balance. So I teach math, and I've dabbled in other subjects, but basically I've taught math, everything from sixth grade up through. I teach community college now. I've taught a little bit at the undergraduate level, but yeah, middle school and high school is sort of more where I've spent more of my time. And then I write these books too. So the my blog is called Math with Bad Drawings, and then I have this series of books that's kind of the Math with Bad Drawings series. So they're all illustrated with stick figures. You know, there's some people out there who do stick figures because they think it's like fun and playful. That's part of the reason I do it, but also it's partly just like I really can't draw, so that's the best I can do. So stick figures, that's me really putting my all into it. And so yeah, they're kind of these four silly books. They're meant to be have some intellectual depth to them. So they really teach you about math, but they're also meant to be fun and playful and accessible. So a lot of my readers are students who are excited about math, 12 and 13-year-olds who just want something fun and playful to go deeper with the subject. And so that's me. I kind of move back and forth between the two worlds where teaching and you're in the classroom and it's always going by in a blur and a million things to do every day, and then writing, you get to sit back and sculpt something and edit it if it goes badly, which the classroom, that's not how it works. You can't have a bad lesson and be like, all right, let me hit the reset button, we're just gonna do that whole lesson again. It happens quicker. So I like the balance of those two.
All right. Well, thank you again. And now your latest one, it looks like, is Math for English Majors, a human take on the universal language. And this really stuck out to me because I taught English a little bit. Mainly I taught history, but I would say, I mean, as a student, as a math student, I struggle. But I used to tell my kids all the time, like, you got any history or any English? I got you. Like, I'll support you and all that. I can tutor you. I can give you that support and needs. However, don't ask me any math questions because it's just never been something I was strong in. And so I'm just so curious about how, because they seem like two totally opposite areas. So start with, how can math relate to English?
Yeah, they do. I mean, I definitely want to honor the fact that for a lot of students, they just feel so separate. They really feel far apart. The kind of thinking you're doing in English, where you get to like look at the text and then share your own ideas and kind of branch off in different ways and have a flowing conversation. And then math, which feels often so rigid and narrow. And it's like, no, you had to put your foot in exactly the right place. You had to write your X in exactly the right spot and do exactly this thing. It feels much narrower, I think, to most students. So how are they actually connected? What I talk about in the book is that math really it's a system of communication. It's for sharing ideas. And the ideas we're sharing in math are kind of funny, very specific sorts of ideas. So the language has been designed in a kind of weird way makes it kind of just the right vehicle, or just the right container for those peculiar ideas we're sharing in math. But basically it all starts from trying to assign numbers to the world. You look at the world, you either count something out there or you measure something with some kind of measurement device, and then you use calculations to figure out new information that you never could have measured in the first place. One of the classic example is the ancient Greek who wanted to know how big the world was. I don't know what transportation technology was like in ancient Greece, but you're not going to travel all the way around the world trailing a big string behind you to measure it directly. So it's like, okay, what am I going to do? You can measure kind of the length of a shadow in two different places. That's a pretty easy measurement. And then you do some math and you can actually calculate, to a reasonable degree of accuracy. He got it to less than 1% error. How big is the world? So that's sort of the template to me for math. It's taking a little bit of information we have and using it to find new information.
Okay, I got you. So not necessarily, or maybe I'm jumping the gun here because I want to make sure I got a clearer picture of how the two of them relate. Because when I think about math, I think of kind of like what you said there. There's formulas.
Yeah.
I guess technically in English there's formulas too, like a sentence, for example. You got to have a subject, a noun, those kind of verbs, those kind of things. And I believe you talked something about that in your book. Can you Can you open up about that?
Yeah, exactly. Yeah. So we can start with nouns. That's where I start in the book. So, right, in English, noun, person, place, thing, sort of anything we're naming out in the world. And I think actually the etymology of noun like comes from name, basically. It's like,
Mhm.
okay, we're assigning a name to that thing. We call it a tree. And in math, that's basically what numbers are. You've got these quantities, and we need to assign names to them. It's really hard. Actually, I showed in the book if you've got like 17 dots versus 18 dots and you're looking at them, like if they're side by side, you can tell that 18 is larger, but there's no way you'd ever, if you were looking at a bunch of pictures with 17 and then 18 and then 22 and then 14, you'd never be able to keep track of how many each one has. So we need to give names to those numbers. You can't count one by one every time. And so the story I start with in the book is I was hiking in Wales. Actually, I lived in England for a little while and was hiking there and came across this really cool plaque that just had on the hillside that showed the numbers in Welsh from like 1 to 20. And you can kind of look, say, okay, when was 1, and like, okay, that looks kind of like 1. And you can kind of get to 10, and then you can see 11 is kind of like 10 and 1. So, a lot of languages work like that. 12 is
Mhm.
10 and 2. And then 15 was kind of its own weird word. And then it got interesting because 16, the way they name it in Welsh is basically 15 and 1, which like it's not how we call it in English. We call it
Mhm.
16 is more like 10 and 6, but okay, 15 and 1. And then 17 was 15 and 2. And then you get to 18, which in English we call it 10 and 8. And in Welsh, I was expecting it to be like, okay, that's 15 and 3. But it's not. It's duna, which is double nines, two nines,
Mhm.
which is like when I saw like when I tell that to people, the two reactions are either, oh, that's really cool. That's a neat way to say 18. Because it is like 18 is two nines. So like you're playing baseball, you got 9 guys on one side, 9 on the other side. Yeah, that's 18. And other people are like, that's crazy. You can't do that. You can't just change the naming system in the middle. And I think both those reactions are right, actually. That like, that is a cool way to say 18. That's if you're talking about the number 18, if we were just giving names to things, that's a nicer way to talk about 18, to say, oh, look, it's made up of two nines. But on the other hand, everything else is based on 10. And so it's much harder as a kid to learn a naming system where what it's based on is changing. Imagine if you had to like know exactly what the factors of every number were, and just in order to be able to count, it's more complicated. It's harder to learn. Anyway, so even just with numbers, even with counting, you've got this naming system that's designed for a lot of different purposes, but among them, one is ideally to be easy to learn. And another one is like the naming system should make it easy to add and subtract numbers, which ours does a pretty good job of. 27 plus 32, you add the 20 and the 30, you add the 7 and the 2, and you can kind of come up just by moving around the names, come up with what the sum should be.
Okay. All right. Well, that makes sense, and it kind of made me think about like Roman numerals as well. How they tend to look like
Yeah.
letters, so that kind of brought that to my mind when you started talking about what you noticed there.
Yeah, and Roman numerals are sort of like, in some ways, an easier system to learn than our numbers, because you think you got to learn 10 different symbols. You got to learn 0 through 9. Whereas Roman numerals, it's almost more like tally marks. And then once you get enough tally marks, or once you get up to 5, it's like that's too many tally marks. So you just call it a V. So Roman numerals, that kind of accumulating numeral system, is sort of a little easier to wrap your head around, but it's not as good for writing pencil and paper arithmetic. It's harder to multiplying Roman numerals would be really tough.
Okay. And so we talked about nouns. So I would imagine nouns could be like variables or something like that within, if we're talking maybe on the high school level of math or something like that.
Yeah, exactly. Yeah.
And then you also talk about verbs. How are verbs related in math?
Yeah. So verbs are tricky. So the story I like to think of is I was visiting my sister who teaches K through 8 math. She's like a math specialist for
Mhm.
a K through 8 school, and we're hanging out with the kindergartners. And she was asked to just like make a conversation with them. She's, oh, how old are you? And they're mostly saying 5. And then she would say, oh, and how old will you be next year? And you sort of figure, I don't know, like you ask me how old I'm going to be next year, I just add 1 to my age. I know what it's going to be. And some of the kindergartners did that, but some of them didn't. Some of them would go, oh, 5, 1, 2, 3, 4, 5, 6. And they had to sort of count again from 1, almost the way sometimes I feel like if you're blanking on the alphabet, like, wait, does Q come before R or after R? You just got to sing the whole song to get there. It was like that, but for numbers for them. And it was funny, what it highlighted for me was that even before you learn addition and subtraction and division and all that, incrementing, just adding 1, that's kind of like the simplest operation there is. Counting, starting at one place and going on to the next number. There's something there. And you sort of doing that repeatedly, that's what addition is, in the same way that like multiplication is repeated addition. And I thought that was cool. It was interesting to realize that at this stage of math where you think kids are just kind of memorizing the names of the numbers, there actually are processes that they're doing. There's, a verb is an action. And so that adding 1, that's a real action for them, and there's easier ways to do it and harder ways to do it, and they're kind of wrestling with that action, and then later, though, when you talk to a 4th grader, 5th grader, they don't have to do that. You say, okay, how old are you? 10. How old are you going to be next year? They just say 11. It's not hard for them, and so what's going on there is they've taken counting, going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it doesn't have to be an action for them anymore. They can just jump straight to the outcome, right? They're like, oh, 10, add 1, it's going to be 11. I don't need to do all the counting. And even though that's pretty simple math when it comes down to it, I think most of us are pretty good at that. That's kind of the template for how math goes. You learn a process like addition or multiplication. And then what you have to do is you have to start, especially as you get into algebra, you sort of stop thinking about the process and start just looking at the outcome. So this is what's tough about algebra. You see 3 plus 5, and you say, okay, oh, it's 8. And you see 4 plus 9, you say, okay, 13. You see x plus y, and there's nothing to do. You're not supposed to do anything with x plus y. That's just two numbers added together, and we don't know yet what they are. They could be any numbers. And one of the things I like to do with students is try to get them to see numbers that way. If you see 10 plus 8, you could call that 18. That's another name for that. But you can also just call it 10 plus 8. That's a perfectly fine name for that number. Same as in English, the equivalent would be like, you can say a dog and a cat, or you can say 2 pets. Then those are 2 ways of saying the same thing, but you don't have to. It's not like if someone says a dog and a cat, you immediately have to say, oh, 2 pets. No one's demanding that you paraphrase it. And that's the same as 10 plus 8. When you see 10 plus 8, like, actually, that's just a number. That's fine the way it is.
Got you. Okay. All right. I'm going to shift gears just a little bit, because when I look at the title, Math for English Majors, first thought that came to my mind was like word problems. So I was like, oh, okay.
Yeah.
This is probably a book about word problems and how, Johnny has 6 apples and Mary has 4. How many do they have together? This is a great way for math teachers to utilize word problems. But it doesn't seem like that is the gist of where you went with things, unless that is part of the book. You have some thoughts there.
We get into a little bit of word problems there. Yeah, I'm trying to think of it. It's funny because the Math for English Majors title kind of came late. The original title was How to Speak Math. And it's funny, like the genesis, I realize as I'm telling these things, it's sort of like, it's a little in the weeds, more so than my other book. So like my first book I did, it's called Math with Bad Drawings, and it's got chapters on like lottery tickets and on triangles in architecture, and on, insurance policies, like sort of weird kind of the insurance policies I pick are all really weird ones, like insuring yourself against an alien abduction or something like that. So that one's sort of like weird little applications of math. And then the book I did before this one, my third one, was a book of mathematical games, like pencil and paper games, sort of stuff that's a little more interesting than tic-tac-toe, but doesn't take as long to learn as chess. There's a lot of space in between those. And so I'd done those 3 books, and I'm happy with them, proud of those books. But I'd felt kind of like I was missing a really crucial part of what trips people up with math. Like before we started recording, we were talking about how, right, for the students that you work with, Algebra 2 is just like a huge stumbling block. Yeah. It's this gatekeeper in the educational system. And mathematical notation often works that way. It's like, can you look at a page of mathematical notation and like, do you just feel this really strong fight or flight instinct to run the other way? Or can you kind of sit with that and make some sense out of the symbols? I see that with students I teach, that's a huge divide of just like, how comfortable do you feel with the marks on the page? And usually when people like me, or like math professors I work with, when they want to get people excited about math, we just like push the symbols under the rug. Just like, no, don't pay any attention to those. Forget about the X's and the Y's. Like, think about these cool shapes, fractals. Think about the golden ratio. Like, we sort of focus on stuff that's a little more visual often and accessible. But then if you look at who's kind of succeeding in math education, you need the symbols. Like to access college level science majors or lots of professions, if we don't teach people how to master those symbols, then there's sort of doors that close. Pathways that aren't open to them. So what I want to do in this book would be like, okay, how do I get 10 years of math education? How do I get down to one little book? I'm not going to be able to cover everything, but what's sort of like the essential understanding and the kind of unspoken part that doesn't always come through, that like expert users of math, they don't know kind of what to say. They don't know how to express that kind of that unspoken knowledge that they have. And I kept coming back to language, because in the same way that like a native English speaker or a native speaker of any language just knows so much about their language they don't even think about. Like in English, one of the classic examples is adjective order, where we always say big blue ball. We would never say blue big ball. It's just like it sounds wrong, like putting the color before the size. And there's a million rules like that we just kind of apply automatically. And my feeling is that math is kind of the same way. So I wanted to sort of unpack some of those rules. What are the things that fluent speakers of mathematics who have learned it, what are the things that they do that they've picked up without really knowing it? And how do we kind of package that together for students? Anyway, that's a very long answer, but that was sort of the genesis of the book. And it really is a language. It just happens to be a weird language. It's a language where we tend to only say things once, That's one really challenging thing about math. In English, a good persuasive essay kind of circles back and repeats some thoughts. And in mathematical text, we just don't tend to do that. You put it down on the page once and now it's been said, and then you move on to the next thought. And so that makes it's kind of slow and painstaking to read. One difference among many.
Got you. Okay. Okay. Well, that makes a lot of sense. I want to leave our audience members, especially, I guess, our math teachers out there, and I guess our English teachers as well. I want to leave them with some strategies that are out there. What could you share with some of our teachers? Of course, folks, we want you to get the book, but what are some of the strategies that are in the book that kind of relates to the concepts that we're talking about today?
Yeah, I think my sort of overall view of math education tends to be you really want to start concrete and then try to build to something more abstract. Doesn't go so well when we try to leap straight to the abstract. Subtraction is maybe a good example. You talk to mathematicians about subtraction, and like, subtraction is just adding the negative. -4, that's just the same as adding -4. That's not how I would teach it to sixth graders. It's really not the right way for a middle schooler to think about subtraction. I try to think about like, what are some really concrete settings where subtraction comes up? And there's a few different models actually where subtraction matters. Taking away is the classic one. You got $20 and you spend 4. But there's other ones. So for example, if right now I'm 50 miles from home and I'm trying to get further down the road to 90 miles from home, how far do I have to go? That's also subtraction, but it's not a taking away, actually. If I'm at mile marker 50, I'm trying to make the numbers a little trickier. Say I'm at mile marker 49 and I'm trying to get to mile marker 92. You can sort of add instead of subtracting. You go 49 to 50. Okay, I've traveled 1 mile. And then 90 is another 40 miles. And then to 92 is another couple of miles after that. And then you can add up those distances you traveled. So that's just the example of subtraction of how to sort of come up with a concrete scenario. But I think almost all mathematical thinking, you got to start with the concrete. So that's one kind of theme that I cycle back to a lot. And another one, not from this book, but from my previous book, actually, on games. You can't cancel math class every day to play games. That's not, I definitely don't advise that. But a couple times during the year, once a month, like it turns out that one day of game playing, instructional time is really valuable. I wouldn't want to waste it. But one day to for one thing, build morale, but also to show students that there's more to math than just the procedures that they're learning, like making time for those kinds of inspirational, exciting lessons. There's a good YouTube channel. So Numberphile is a fun one that has lots of good videos out there. Matt Parker does great YouTube videos. You're finding the stuff, and then different games that can get students thinking mathematically, but in a way that's playful and fun. Yeah, I definitely don't advise teachers abandoning the curriculum for just game playing all the time, but sprinkling it in, finding those 10 minutes on a Friday to play a game can just make a huge morale difference.
I always, one of the biggest things that I've learned from speaking with guests that math was their focus, finding ways to relate the concepts to a student's home life or what they're interested in. So kind of hearing you talk about gaming, for example, like you're going to have a lot of students that might be interested in games and how you can relate all of that. And just being able to say, okay, what can I do to make that connection for this individual student that, again, math tends to be one of their harder subjects. However, it doesn't mean that it's an impossible subject, but it might just require me to find ways to relate that information to them.
Yeah, no, exactly. Yeah. There's sort of the two kind of branches in trying to make math accessible and exciting for students. I think of it as there's the quote unquote real world branch where you say, look, here's how math connects to things out there in reality. Often it's as simple as just putting dollar signs in front of everything. Like kids know money. Kids care about money. So when teach negative numbers to middle schoolers, when I've taught that in the past, there's lots of different models people like to use, and visual models and number line models. And for me, the one that always clicks is talking about debt. Like if you owe your friend $3, that's my sixth graders, that's visceral for them. They get that idea. Like, oh no, I owe $3. If you owe that kid $3 and you owe that kid $9, oh my God, now you owe $12. Like that's very concrete for them. And then you connect that to the sort of abstract representation of negative numbers. So that's sort of door number one. Path number one is try to make it real concrete. And then path number 2 is try to make it sort of like fun puzzles. This can feel harder because especially for students who are not inclined to see math as a set of fun puzzles. But one of the moves I like there is to sort of loosen the question a little bit, where instead of saying, find the area of this rectangle and find the area of that rectangle and find the area of that rectangle, you say, give me a rectangle whose area is 12. Any rectangle, you can come up with it. Or give me a rectangle whose area is 100. And then you look around the room, you're like, oh, actually, yeah, those 3 kids all did the same thing, but those 3 kids all did a different thing. And here, that's the only person who gave that answer. That's an interesting answer. Let's dig into that. So that one's takes a little more agility from the instructor to make sure to pick out the answers that are going to lead to productive conversation. But it's a really important move, I think. And you can do that with any math. You can always say, okay, rather than me giving you the example, you give me the example. Give me an equation where the solution is 4. Some kid will be clever and be like, my equation is x equals 4. There, solution is 4. And like that's actually a good starting point to talk about. And some other kid will be like, okay, well, x plus 1 is 5. You go, okay, yeah, that one, again, 4 works. And some kid will try to be clever, be like, well, x squared minus 19. They'll do something very complicated.
Yeah.
And then that one gives you a different kind of conversation. You can kind of steer into what the right level is for the class to discuss together. But I find that is both more engaging for the student because they're being asked to think in a slightly different way. They're being asked to produce something rather than just rehearse steps. And so it's more engaging, and also is in some ways a better test of understanding, because it's often the case in math that we learn the dance, we learn here are the steps you follow, but what do the steps mean? What are they producing? It's like we're doing the dance, we're not really hearing the music. And just asking somebody like, show me how you would dance to this, or you come up with the music yourself almost. Yeah, it can kind of open the subject up a little bit.
Got you. Okay. Well, listen, I'll tell you one thing, folks. Math for English Majors sounds like a book that I definitely need to get my hands on. And I'd love for you to share with our audience, because I've learned so much so far. Share with our audience any last words of advice you want to provide to our listeners.
Yeah, I mean, right. Depends on where sort of you sit in the educational system, I guess. For elementary teachers, I love working with like primary school teachers, and some are really excited about math. Typically, that's not the subject that's drawn them into teaching. Often they're excited about literacy, or they're excited about social studies, or like social and emotional development. So I would say keep in mind that like you can still grow as a mathematician. That would be my main advice for them. That like I've seen it with high school math teachers too, people that I've worked with, where they came in first year in the profession and like maybe their knowledge was not actually as strong as they wanted it to be, but you give it time and you keep working on it, and your own learning is always important in teaching. It's sometimes easy to forget as we're telling the students how important their learning is. But like, yeah, our learning is important too. You learn something better, and now there's the rest of your career, those students are going to learn from you. And so I'd say, yeah, for elementary school teachers, you prioritize your own learning and growth when it comes to math. And then for high school teachers, those are sort of already in the math world, yeah, I would say embrace the idea that math is connected to other subjects. It doesn't need to stand alone as this pure, pristine, untainted thing. That I think math is best when it's got partnerships, when it's in companionship with other ways of thinking.
Oh, I love it. I love it. All right. Well, Ben, if we got some folks that want to connect with you, what's the best way to reach you online?
Yeah, sure. Yeah. My blog is Math with Bad Drawings. And then that's also the name of my first book. I'm on sort of reluctantly still on Twitter/X, just Ben Orlin. It's also slightly less reluctantly maybe on Instagram, Math with Bad Drawings. And then my email is just mathwithbaddrawings@gmail. So you can reach out to me any of those ways. And I love hearing questions from teachers in different settings. So part of what I really like about doing the books is there are these little ships in a bottle, and I get to hear from people in all different kinds of schools and different places that I've never actually been able to travel to, and get to hear letters back about what they're doing in class and what math means to them.
All right. Well, that sounds awesome. Ben, thank you so much for your time. It's been a pleasure.
Yeah, no, appreciate it, Sheldon. Yeah, thank you.